All right, today we are diving into something that honestly powers pretty much our entire connected world. We're talking about REST and RESTful APIs. You could almost call them the unsung heroes of the internet. I mean, have you ever really stopped and wondered about that? How does your weather app, your stock app, and yeah, even your food delivery app, how do they all have the latest up-to-the-minute information? All these different apps made by totally different companies, they just seem to magically have what you need right when you need it. Well, it's not magic, but it is incredibly clever. So, the secret, it all comes down to a standardized set of rules. Think of it like a common language that lets all these different programs talk to each other, seamlessly. And that language, that rule book, is often defined by an architectural style called REST. So, here's our game plan for this explainer. First, we'll look at how the internet even talks in the first place. Then, we'll introduce a really helpful analogy, the digital waiter, to understand REST. After that, we'll get into the actual language, the commands, and see an API in action. And finally, we'll wrap up by looking at why REST is just, well, it's everywhere. All right, let's get right into it. To really get a handle on REST, you first have to understand the problem it was designed to solve. And that core problem is, how do totally separate computer systems talk to each other effectively over a network, like the internet? So what exactly is REST? Well, the full name is Representational State Transfer. And yeah, I know, that sounds pretty complicated, right? But just forget the name for a second. Think of it simply as a rule book. It's not a program, it's not a specific technology you install, it's just a set of guiding principles, a style guide, for how web service should be designed so they can be efficient, scalable, and reliable. Okay, to make this whole rulebook idea really click, let's forget about computers for a minute. Let's think about something we all understand: ordering food at a restaurant. This is what we're going to call our digital waiter analogy, and it makes everything so much clearer. Okay, this is where it all starts to make sense. So in this restaurant scenario, you, the customer, you're the client. That's your app asking for something. The kitchen, that's the server. It's where all the food, or in our case, the data, is stored and prepared. The resource is the specific thing you want, an item on the menu. And the most important piece of the puzzle, the waiter who runs back and forth between you and the kitchen, that's the API. The API is just the messenger, the go-between that handles all the communication. Now, here's a really, really important rule for our digital waiter. It's called statelessness. Basically, the waiter has zero memory of your past orders. You can't just walk in and say, "I'll have the usual." It doesn't work. Every single time you ask for something, your request has to contain all the information the kitchen needs to fulfill it. Now, that might sound inefficient, but it's actually the secret sauce for scalability. It means the kitchen, the server, doesn't have to keep track of thousands of ongoing conversations. It just deals with one order at a time. Okay, so our waiter is standing there, notepad ready. But how do we actually talk to them? What's the language? We need a clear set of commands to tell the kitchen exactly what we want done with our food, or, our data. Well, that language is built on something called standard HTTP methods. The easiest way to think about these is as action verbs. They are the specific commands, the verbs, that you give to the waiter to pass on to the kitchen. And really, there are 4 main verbs that do most of the work. A GET request is just asking to read some data. It's like saying, "Get me the menu." A POST request is used to create something new, like placing a new order. PUT is for update. You're changing an existing order, maybe saying, "Hey, change my steak from medium rare to well done." And delete, well, that one's pretty obvious. It's for delete. You're canceling the order. These 4 actions, create, read, update, and delete, are so fundamental, they even have their own cool acronym, CRUD. All right, the restaurant analogy has been super helpful, but let's see how these CRUD commands work in a real digital scenario. So let's leave the restaurant behind and step into a digital library that's managed by a books API. So first up, let's say we want a list of every single book in the library. Our app sends a GET request to this address, /books. We call that an endpoint. The API, acting like our librarian, goes and grabs the master list and sends it back to us in a nice structured format, usually something called JSON. That's it. Simple. Okay, but what if we don't want the whole library? What if we just want one specific book? Easy. We just add its unique ID to the request. So get/books/1 is basically telling the API, "Hey, don't bring me the whole shelf, just find the book with ID number 1. And that's exactly what it sends back. Now, let's say we want to add a brand new book to the collection. For that, we use the POST method. We send a post request to that same /books endpoint, but this time we also include the new book's details, like the title and author. The API adds it to the library and then sends us back a confirmation. It's not the data itself, but a status code, like 201 created, which is just the system's way of saying, got it. The new book has been added successfully. But what if we find a typo in a book's title, or we want to update its information? That's where put comes in. We send a put request to that specific book's address, /books/1, and we include all the new corrected information. We're telling the API, hey, replace the old data for this book with this new data. And again, we get a status code back, like 200 OK, which is pretty much the universal signal for, yep, everything went perfectly. And finally, if we want to remove a book from the library altogether, we send a delete request to that book's specific address, delete/books/1. The API goes into the database, removes it, and sends back a response like 204 no content. This one literally means I did it and there's nothing left to show you. And just like that, the book is gone. See? It's a really clean, logical, and predictable system. So we've seen how it all works. It's clean, it's logical, it's predictable. But that really brings us to the biggest question of all. Why? Why has this particular set of rules become the de facto standard for almost the entire internet? Well, the reasons are pretty powerful. First, scalability. Remember that statelessness thing? Because the server doesn't have to remember past conversations, it can handle millions of different requests at the same time without breaking a sweat. Then there's flexibility. REST doesn't really care what format the data's in. It can be JSON, XML, whatever. It's also simple. It uses the same basic HTTP commands the web has been using for decades. And all of that leads to the big one, interoperability. Basically, if a device can speak HTTP, which is pretty much everything connected to the internet, it can use a REST API. So really, when you boil it all down, that's what REST is. It isn't a physical thing you can point to. It's the invisible grammar of the internet. It's that shared set of conversational rules that allows your phone to talk to a weather server, your laptop to talk to a stock market database, and yeah, maybe even your smart fridge to talk to a grocery delivery service. It's this invisible architecture that connects our entire digital lives. And by understanding these simple principles, the client, the server, the request and response, and those few action verbs, you now understand the fundamental way that modern applications share information across the globe. So I guess the only question left is, now that you know the language, what could you build?